Hi guys, this is Miss Igo. Welcome to my classroom. In today's video, we're going to be talking about graphing inequalities. An inequality has some symbol other than an equal sign, like this equation has a greater than or equal to symbol. So it could have greater than or equal to, less than or equal to in order to be an inequality. In order to graph the inequality, we can graph it just like we would any line. There's just a few extra steps or extra things that we need to take into consideration. In this inequality, it's already in slope-intercept form, and I think that's probably the easiest method for graphing a line. You could also do a t-table, or you could find the intercepts, but we're going to be graphing by getting our equation or our inequality in slope-intercept form. Slope-intercept form is y equals mx plus b. And when we have an equation in that form, the m represents the slope of the line and the b is the y-intercept. So let's pull those out of this inequality. Like I said, it's already in that form, so we just need to pull out the information. The slope of this line is 1/3, and the y-intercept, which is represented by a b, is -3. To graph the line, we begin with our b at -3. Again, this is our y-intercept. Let me go ahead and write that this is the slope. So on our y-axis, we're going to go down to -3, 1, 2, 3, and put our first dot. And from that point, we're going to use our slope to do rise over run. So our rise is 1, that means we're going to go up 1, and our run is 3, it's a +3, so we're going to go to the right 1, 2, 3 spaces. I'm going to do it one more time. I'm going to rise 1 and run 1, 2, 3. Okay, that's the same thing that we would do, and then of course we connect our points to draw our line. So that's the same way that we would just graph a line. When we're dealing with inequalities, an extra step that we have to take into consideration is what kind of line we're going to draw. So our lines sometimes will be solid and sometimes they'll be dashed. If we have less than or equal to or greater than or equal to, then our line is going to be a solid line. If we just have less than or just greater than, then we're going to have a dashed line for our graph. And the way that I remember this is if we have that line underneath our inequality, that just reminds me that it's a solid line on my graph. So in this case, we have greater than or equal to, we have that line underneath our inequality symbol, so we're going to have a solid line on our graph. Now the other step that we have to take whenever we're dealing with inequalities is we have to shade one side of the line. Because this is an inequality, everything on one side of the line is included in the solution set of the equation, of the inequality. So there are a couple of ways that we can determine which side of the line needs to be shaded. We can pick a test point and test that test point. And if we choose to do that, we are testing to see if that side of the line is part of the solution set of the inequality. The easiest test point to pick is 0, 0. The only time we can't pick 0, 0 is if our line is crossing through that point. This line is not crossing through 0, 0, so I'm going to use 0, 0 as my test point. That means that I'm testing the point 0, 0. So my x is 0 and my y is 0. If I plug that into the inequality, I'm plugging in 0 for y is greater than or equal to 1/3 times 0 for x minus 3. That gives me 0 is greater than or equal to, this 1/3 times 0 turns to a 0, so it just goes away, minus 3, or negative 3. So now this statement says that 0 is greater than or equal to negative 3. And that's a true statement. So that tells me this point that I just tested is on the true side of the line. Therefore, I'm going to shade on that side of the line. If it were not true, I would shade on the opposite side of the line. I always want to shade on the side that is true. So I'm going to shade everything on this side of the line. Just to explain to you a little bit more about test points, if I were to choose this point right here, this point is 3, -3. 3, -3. If I were to take that and plug that into the inequality, that would give me, I'm plugging in 3 for x and -3 for y. So that would give me -3 is greater than or equal to 1/3 times 3, or 3/1, minus 3. If I simplify that, I get -3 is greater than or equal to, if I multiplied 1/3 times 3, I get 3/3, which is 1, minus 3. And that says -3 is greater than or equal to -2. That is not a true statement. -3 is not greater than or equal to -2. So any point I chose below this line is going to make our statement false. Now I'm going to teach you a shortcut. As long as your inequality is in slope-intercept form, so this form right here, then you can use this shortcut. You cannot use it if it's not in that form. If it's not in that form, you can get it in that form and then use it. But you must get it in slope-intercept form first. If it's in slope-intercept form, we can look at the inequality. And if it says greater than or equal to, we shade above the line. If it says less than or equal to, we're going to shade below the line. So as you see here, this said greater than or equal to, and we shaded above the line. Okay, let's try another one. This inequality is already in slope-intercept form once again. So let's pull out the pieces of information that we need in order to graph the inequality. My slope is -3. If I want to change it to a fraction so that I can graph rise over run, then that would be the same thing as a -3/1, or 3/-1. Anytime our slope is negative, make sure that we put the negative sign with either the numerator or the denominator, but not both. If both the numerator and the denominator are negative, that would be a negative divided by a negative, which is positive. And our slope is not positive, it's negative. So make sure just one of them is negative. And then our y-intercept in this case is a +2. Again, to start graphing, we begin with our B, which is our y-intercept. Starting at 0, we're going to go up 1, 2 spaces on the y-axis and put our first point. And then my slope, like I said, is either -3/1 or 3/-1. If I do -3/1, I'm going to go down 3 and to the right 1. Down 1, 2, 3, and to the right 1. Or if I did 3/-1, that means I would rise 1, 2, 3, and then go to the left a -1. Rise 1, 2, 3, and go to the left 1. Again, we need to determine whether our line is solid or dashed. And because our inequality symbol has the line underneath it, less than or equal to, then our line is going to be solid. So I'm going to draw a solid line connecting my dots. And then we need to determine what side of the line we shade on. Well, this is less than. Less than means we're going to shade under the line. I've had students before that weren't sure which side was under and which side was above. If I wanted to get under this line to be protected from the rain, I would get on this side. If I got on the other side, if I got over here, I'm going to slide off of it, right? That's getting on top of the line. And we want to be under the line. So this side is under the line. Okay, here we have an inequality that is not in slope-intercept form. So let's get it into slope-intercept form first. Remember, the y needs to be by itself. So I'm going to subtract the 2x from both sides of the inequality. That gives me a negative y is greater than negative 2x plus 3. We need our y to be positive, so we're going to divide everything by a negative 1. And when we're dealing with inequalities, anytime we multiply or divide both sides of the equation by a negative number, we need to flip the inequality symbol. So that's going to flip from greater than to less than, and that would become a positive 2x minus 3. All right, it's very important that you flip your sign when you need to, your symbol when you need to. Otherwise, you're going to be shading on the wrong side of the line. Okay, now that it's in slope-intercept form, let's pull out our slope, which in this case is a 2, and our y-intercept, which is a negative 3. So again, we begin with our b. So on our y-axis, we're going to go down 1, 2, 3. And then my slope is 2 or 2 over 1. So I'm going to rise 1, 2, run 1. Rise 1, 2, run 1. And I can do that as many times as I want to. And then we need to determine what kind of line it's going to be. And in this case, it's going to be a dashed line because there's no line underneath my inequality symbol. It's strictly less than. So let's do a dashed line. Not a very straight dashed line, but you get the picture. Okay, now again, we look at it when it's in slope-intercept form, not the original form of the equation, in order to see which side of the line we shade on. And this is less than, so that means we're going to shade below the line, under the line. All right, so this is the side that's shaded. Like that. When you have just an x or just a y in your inequality, you can't put it in slope-intercept form. And I explained a shortcut on how to remember the way that we graph these types of lines in my video about how to graph linear equations. That shortcut is to remember the acronym HOI-VUX. That acronym reminds us that all horizontal lines have a slope of 0, and their equation is y equals some number. Vertical lines have a slope that's undefined, and their equations are x equals some number. So because we know that, we can graph these inequalities using the same method. This is x is less than 3, and so it's the same as if we were graphing x equals 3, which tells us it's going to be a vertical line. So we're going to draw a vertical line through our x-axis at 3. So I'm going to go over to my x-axis and put a dot on 3, and then we're going to draw a vertical line. Now we need to see what type of line we're going to draw because this is an inequality. And since we just have less than, not less than or equal to, we're going to put a dashed line. So we have a dashed vertical line going through x at 3. And now we need to shade one side of the line. Well, we definitely don't have an under or over or below or above when we have a vertical line. So just think of it this way. This says x is less than 3. X is all of the numbers. So this is saying all of the numbers less than 3. If we look at our number line, our x-axis is our number line. All of the numbers to the left are going to be the numbers that are less than. So that means we're going to shade to the left of our number line. Of course, if it said greater than, all of the numbers on the number line that are greater than that number would be to the right of the line. And this is our last example. Y is greater than or equal to -1. So based on the acronym that we just went over, HOI tells us that all horizontal lines have an equation that just contain a Y. And we're going to go to our y-axis at -1 and put a dot, and then we're going to draw a horizontal line through that dot. This time, because it's greater than or equal to, we're going to draw a solid line going through y at -1. And it's greater than or equal to, so the numbers that are greater than are going to be above the line. So let's shade above the line. And that's it. And that's how we graph linear inequalities. If you enjoyed this video, make sure you hit the like button, and if you haven't already done so, please subscribe to my channel. If this video helped you, make sure you share it with your classmates. Thank you for watching.